Unit is over complex fractions and unit rates. So let's talk about rates, our last lesson. Rates is comparing two different quantities with different units. After 4 hours, Pasha had traveled 217 miles. If she travels at a constant speed, how far would she have traveled after 1 hour? So this is rates or unit rate, because I want a denominator of 1. I would like to know this. There are two ways you can do this. You can do it with the bar diagram if you would like this. I have 217 miles. I need to break it down for every 1 hour. So I divide. Got a remainder. 0.0. Before going 10, 2 times. Got rid of remainder, add another 0. So it's 54 and 25 hundredths mile for every 1 hour. Another way you can do it is through the box method. How do you turn 4 hours to 1 hour? You divide by 4. You're scaling down by 4. Scaling it down by 4. And you would got them 54 and 25 hundredths. So a complex fraction is a fraction where the numerator and denominator are both contain a fraction. Here is a fraction with a fraction. Here's a numerator that has a fraction. Here's both, the numerator and the denominator both have fraction. So a construction worker is blacktopping a driveway. She blacktops 35 and a half square yards in 5-6 hours. How many square yards can she blacktop per hour? Per hour means for every 1 hour. So how do you, are we putting up or breaking it down? We're breaking it down. How do you break it down scale down from 5-6 hours to 1 hour? How do we scale it down? I'm going to divide by 5-6. Divide by 5-6. 5-6 divided by 5-6 is 1 hour. Ooh. Solve 35 and a half divided by 5-6. Ooh, do I remember how to divide fractions? Oh, turn this to improper. That's 71 over 2. 35 times 2 is 70 plus 1 is 71 2. Divide by 5-6. So how do you, is there another way to rewrite this division fraction as a multiplication expression? Oh, yeah. You flip the reciprocal. That would be 426 over 10. 71 times 6 is 426. 2 times 5 is 10. How many groups of 10 go to 426? 42 groups. The remainder is 610. That can be simplified to 42 and 3/5. So, at 5-6 an hour, that's like, if I have to say, that's about like 50-something minutes. If she does it for 1 hour, you're building up for here, then she will be doing 42 and 3/5 square yards. Next one. Mr. Ito is spreading mulch in his yard. He can spread 4 and 2/3 square yards in 2 hours. How many square yards can he mulch per hour for every 1 hour? Are we scaling up or scaling down? We're scaling it down by dividing by 2. So what's 4 and 2/3 divided by 2? Improper fraction. Let's turn this into proper fraction. 14/3 divided by 2. So let's turn this into a multiplicative expression. So what do? We do the reciprocal of it. If you went to Patterson, your teacher taught you to divide fractions. You keep, change, flip. So we get 14/6 or 7/3. Another way to say 7/3 is 2 and 1/3. So 2 and 1/3 square yard in 1 hour. So we're divided by 2. Aubrey can walk 4.5 miles in 1.5 hours. Find her average speed in miles per hour. That's for every 1 hour. So help me break this down from 1.5 hours to 1 hour. I divide by 1.5. Divide by 1.5. 4.5 divided by 1.5. Turn it to improper fraction. That's 9 halves. Improper fraction, that's 3 halves. Do you know another way to rewrite this division expression as multiplicative expression? You do the reciprocal of this. That's an 18 over 6 or 3. 3 miles every hour. 2 hours will be 6 miles. So 1.5 hours will be 4.5 miles. Mr. Joe's fan club are making spirit buttons. They made 490 buttons in 3.5 hours. Calculate the number of buttons a fan club member made per hour. That's for every 1 hour. No students were hurt in the making of the spirit button. So I need to break this down by dividing by 3.5. 3.5. So that'd be 1 hour. So 490 divided by 3.5. Let's turn this to an improper fraction, 7/2. How can I rewrite this as a multiplicative expression? I do the reciprocal of this or keep change flip. So what's 490 groups of 2 sevens? That would be 0, 18, 980 over 7. If you divide this, I hope it goes in evenly because you can't really make partial buttons. Perfect. 0, 140 buttons in 1 hour. So every hour they make 140 buttons. In 2 hours they make 280 buttons. In 3 hours, 140 plus 140 plus 40, 140. So we have an activity with this. There are 4 families. I would like to know how many miles they can drive in 1 hour. So we have our first family. They drove 210 miles in 3 hours. But I want to know how many they could drive in 1 hour. So I break it down by 3. I scaling it down. So 70 miles for every 1 hour. Fast drivers. They drove 306 miles in 4.5 hours. I want to break this down to 1 hour. So I divide by 4.5. So 306 divided by 4.5. Improper, that's 9/2. 306. What's another way to rewrite this division expression as a multiplicative expression? 306 times 2/9. You do the reciprocal of the second one. So what's 306 groups of 2/9? That would be 612 over 9. Or, let's divide this. 612 divided by 9 is 8, 7, 6. That's 54. That's 5, 6, 7, 8, 9, 10, 11. 72. 9 goes in 72 8 times. So it's 68 miles per hour. And then you keep on doing the rest. So I could just say that they are a really fast driver. For every hour, per hour, they drive 70 miles. So what we're learning about complex fraction is you can break it down into units, into whole number units to help it easier to understand. That's what we did right here. 4.5 hours. I want to know how many they could drive in 1 hour because I want to compare all of them together in an equal comparison of 1 hour per hour. So 68 miles per hour. So again, you're scaling it down. Sometimes you scale it up.